Hello and welcome to our section on conditionals, flow control, and loops. In this section, we're going to learn how to tell Python to make decisions and perform repetitive tasks. We're also going to switch over from writing single statements and expressions in the Python interactive shell to writing complete, if simple, Python programs in their own source code files. First up is conditionals. A conditional tells Python that it needs to make a choice, and more than that, it tells Python how to make the choice. In this video, we're going to learn about condition expressions, conditional decision-making, and the flow of execution when a Python program runs. Python has two versions of the basic conditional. One is a statement, and one is an expression. The statement is for choosing between different possible actions, while the expression is for choosing between different data values. We're going to be concentrating on conditional statements today, but we'll take a glance at conditional expressions at the end. No matter what version of conditional we're using, it always comes down to this: a yes or no question that can be answered with the available information. If the answer is yes, Python does one thing. If the answer is no, Python does something else. Conditional statements are useful for making the program decide whether or not to take a particular action, or for choosing one of several alternates. Here we have a basic Python program, which asks for a name and prints out a greeting. In the middle, though, we have a conditional statement, commonly referred to as an if, because it's identified by that keyword. After the word if, we have an expression not name.isAlpha. Not is an operator, which reverses the truth value of the nested expression. The isAlpha operation checks whether a string consists entirely of alphabetical characters, resulting in true if it does, and false if it does not. Thus, the total expression evaluated by the if produces true if the string contains non-alphabetic characters. The if statement looks at the result of that expression and uses that value to decide whether or not to run the indented code, which makes up its contained block. Here we've seen it work. When we put in only letters, it skips over the if statement's contained block. When we put in something else, the contained block got run. The kind of expressions we're using here, expressions that provide a yes or no result, are called Boolean expressions, and they're important. We saw the true and false values in the last section, but Python can turn any value into something equivalent to true or false, using some fairly simple rules. Basically, there are a few values that are considered to be equivalent to false, and anything else is considered equivalent to true. The number 0 is a false value, and so are empty data structures, empty strings, and the special none value that we saw briefly. Essentially, everything else is a true value. So when we use an expression as the condition of an if statement, Python applies those rules to decide whether or not the expression's result value is equivalent to true, meaning yes, or false, meaning no. If we tell Python to do something conditionally, and pass it a list as the condition value, what the program actually does will depend on whether that list is empty, and so on. In our previous example, the if statement contained a block, and ran that block if the condition was met, or skipped it otherwise. Either way, after it was done, the program went on to the next instruction. However, we can extend an if statement so that it has more than one contained block. It will still only run one of them before moving on, so we can tell Python to consider several alternatives. Here we've got just two alternatives, one that has a condition and one that's marked by the else keyword that has no condition. Else means, if none of the conditions matched, do this. So in this case, we're saying that if the option is equal to hello, we should print out the hello world message, and in any other situation, we should print out the error message. Here we've added even more contained blocks, each of which has its own condition expression. Python checks each condition in order from top to bottom, and it runs the block for the first condition that produces a value equivalent to true. If none of the condition expressions is equivalent to true, the else block gets run. The elif and else sections are both optional. We can add as many or as few elifs as we need, and we can add an else at the end if that makes sense, but we don't have to. It's all about the shape of the decision we want Python to make. As promised, here's a look at Python's conditional expression, as opposed to conditional statement. A conditional expression contains three sub-expressions, one before the if keyword, one after the else keyword, and one in between. The one in between is the condition. If it produces a value equivalent to true, the value of the whole expression is the value of the sub-expression before the if keyword. If it produces a value equivalent to false, the value of the whole expression is the value of the sub-expression after the else keyword. There's no elif for a conditional expression, and the else is required because expressions always have to produce a value. In this example on the screen right now, we're using our conditional expression to check whether the first letter of the name is capitalized. And if it's not, we're substituting the name Floyd in place of whatever the user typed. If it is, the conditional expression evaluates to the same value the name already has in it.